Okay, so number 4. So we left off on number 4. A manufacturing company determines that once it's started a new TV advertising campaign, its monthly change of sales was proportional to the, so there's our, doesn't say directly proportional, but it says was proportional to the current monthly sales, okay? So in January, it sold 5,000 units, and in April, it sold 7,000 units. Write and solve the differential equation that describes the relationship. Okay, so first thing, what are the two variables? What are the two variables that we're comparing? Month, right? Time. And the units sold, right? Units are units sold. TVs, right? They're TV, or, I don't know, it doesn't say what it is, just as advertising. Yeah, so units, whatever they're selling. Okay? So time is going to be our, let's see, monthly sales in units, right? So I would use T. So again, we don't want to use X and Y. You can use X and Y. You can say X is months, Y is units, or you can make it a little more personalized for this one. So for this guy, I'll use S for sales. So capital S for sales and T for time. Okay. So what's our differential equation going to be comparing these two guys? Using T and S, or S and T.
ds over dt.
ds over dt, right? Equals K times the dependent, which is S in this case. Okay. Next thing. What needs to move to the left? What needs to move to the right? S is to the left.
And the T's on the right.
T's on the right. Okay. So you can do this part in your head. You don't need to show me this because we've done this lots of times. So it's going to be 1 over S ds equals K times dt. Okay. Again, all of this part is repeat. Every single problem, 1, 2, and 3, we did this. Okay? It's always going to have that. It's always going to repeat itself for these types of problems. Okay, so the antiderivative, 1 over S, is natural log of S. I should put bars. Actually, sales will always be positive, so bars aren't that important for this problem. Because you can't have negative sales. Either you sell or you don't. So the lowest sales could be a 0, right? And then the antiderivative of the other side would be kt plus c, lowercase c. And then we change it to solve. There's nothing to plug in. We can't plug in anything because we don't have any points. So what we're going to do is we're going to change it to an exponent, right? So e to the kt plus c equals s. All right. So s equals, and then remember, e to the c is the initial amount. Okay, step 2 is done. So what do I got to do next? There's a couple things I could do next, but what's another step that I need to tackle?
Plug in.
Plug in what?
Well, you should make a chart.
Okay, table. Let's do that. Definitely important. Make a table. Okay. T and sales. So what do they give us? They said in January it sold 5,000 units. In April it sold 8,000 units, or 7,000 units. Sorry. So how do we express that in our table?
So initially it was 5,000.
So what's time for initial? What would time be?
0.
Okay, 0. So if January is 0, what is March? Or sorry, what is April going to be? Careful. 3. Yeah, not 4. Because if January is 0, we start 0, February is 1, March is 2, April would be 3, yeah. And that's 7,000 units, right? And then that's all they gave us, right? Okay, good. What else should I do now?
Plug in T3 for T and
Not quite ready for that part yet. Not quite ready for that part. You're right, we'll do that. But before we do that, what do I need to do first? Plug in the initial, right? This guy is your initial, right? This guy is your initial, 5,000. Times e to the kt. Good. All right. So now bring me that step, Celeste. What was that step you said to do next?
plug in 3 for T and 7,000 for S.
And that will do what? You're right. What will that do if we do that, when we do that?
We would find K.
Okay, good. So let's do that. Let's do that. So 7,000 for S and 3 for K. So I'll just put 3 times K. All right. Okay, so we got to solve for K. What do we got to do first? Divide by 5,000, good. Divide by 5,000, divide by 5,000. So the zeros are going to cancel out, so you're just going to be left with 7 over 5. You don't have to change, you can change that to a decimal, because remember, these are calculator questions, or you can just leave it 7 over 5. Up to you. Okay, so we got e to the 3k. K's up in the sky, right? The variable's up in the sky. What's the only way to bring something down to the ground? By using a log, right? So how do we change an exponent to a log? The L, right? The L. So again, just a reminder how we use the L. Keep your exponent to the left. And then right? So it always starts with a log. Log of what? Log of E, which is a natural log, right? So natural log. Natural log. So the L hit the E first, that's why it's a natural log. It's a log with a base of E. 7/5 in parentheses equals 3k. Last step, divide by 3. So we get k equals 1/3 times the natural log of 7/5. So I'm going to go back over here and rewrite it. S equals 5,000 times e to the 1/3 times natural log 7/5 times t. That's when they said write and solve or a formula, that's it right there. Okay, that's the guy we want. Okay, so now B. B says, how long did it take for sales to go from 10,000 to 15,000? Okay, so let me bring my table down. Same table. So from earlier, we had 0, 5,000. Then we had 3, 7,500. So where are 10,000 and 15,000 going to go?
In the S column.
In the S column. Good. The question is saying how long. So what it's asking is, what are those two numbers? That's what it's saying. What are those two numbers, and then subtract them, right? How long? So what are those two numbers, and then subtract them? So how can we figure out what each of those is? Solve for t, right? We got S, solve for t. So let's bring our formula that we just found. So we said S equals 5,000 times E to the 1/3 times natural log of 7 over 5 times t, right? That was our formula. We got S, so let's plug it in and solve for t. What do I do first? Divide by 5,000. 10,000 divided by 5,000, it's half. So it's going to be 2. E to the 1/3 times natural log 7 over 5 times t. Well, I can't divide anymore. I got to bring the big guy down. I got to bring the big power, that power down to the ground. So I'm going to move these guys over here. Just going to switch this side with 2. The only way to bring stuff down to the ground is by using a log. So I'm going to use the L to do that. So natural log 2 equals 1/3 times the natural log of 7/5 times t. So I want to solve for t. So how do I do, what's my next step going to be? Divide by everything you don't want, right? So divide by 1/3 times the natural log of 7/5. Well, instead of dividing by 1/3, that's really just multiplying by 3. So over here, I'm going to put a 3 over here. It's really just multiplying by 3. Okay? That goes away. Now I bring out my calculator, and I figure out what t is. Okay? So you could put the 3 on top, or you can just say 3 times the whole thing. It's up to you. Whatever you want to do. Just make sure you multiply it by 3. So I'm going to go to my calculator. There we go. Make it smaller. Okay. So I have, let's see, division. Oops, I don't want that. 3 times division. I have natural log of 2 over the natural log of 7 over 5. I get 6.180. 6.180. Okay. What does that number represent? Time, right? Months, right? It represents a little over 6 months after January. So what month is it? If it's a little after 6 months, when would it happen? July. So a little after 6 months. So let's go write that down. 6.81, sorry, 180, 6.180. So that goes with 10,000. Okay. 6.180. Sometime in July. Sometime in July, the sales will hit 10,000. Okay. Now what I want you to do is figure out 15,000. When does 15,000 happen? So you should get 9 point something. One third times natural log 7/5 times t. So divide by 5,000. You get 3. So then you get e to the 1/3 times natural log of 7/5 times t equals 3. Bringing the power down. So you're going to get natural log of 3 equals e to the 1/3 times natural log of 7/5 times t. Wait, nope. Put the e in the wrong spot. The power should be over here, just the power. So that guy right there. The e is down here. That's where the e is. Divide by what I don't want to keep. So again, dividing by 1/3 is the same thing as multiplying by 3. Put that in your calculator, and you get 9.795. 9.795. Okay. So sometime in October. Okay. Does that answer the question? Have I answered the question yet?
No.
No. How do I answer the question?
Subtract, your two t's from each other.
Yep. Subtract how long, when were you, t is when were you. When were you at 15,000? Well, sometime in the 10th month. When were you at 10,000? Sometime in the 7th month. Subtract them. A little over 3.5 months. So it took a little over, so it took about 3.615 months. So a little over 3 months. It took a little over 3 months to go from 10,000 sales to 15,000 sales. Okay. All right. Okay. So that's all the problems I have on there. But there's one more problem that I didn't put on there, and I should have. Okay. So here it is, right here. So somewhere on there, put this problem on here. You don't need to write the whole thing down. Just know that. What's the important stuff? Okay. Because this one's a little bit different. It's got a little bit of a wrench that they threw in there. It's the same type of problem, but they threw a little bit of a wrench. So somewhere in your notes, either on another sheet of paper or you can find somewhere on there. Let's do this one. Okay. So in a certain culture, so we got bacteria again. It's a bacteria problem. In a certain culture where the rate of growth of bacteria is proportional. There you go, is proportional to the amount present. The number triples every 4 hours. If at the end of 12 hours there are 10 million bacteria, how many were present initially? Okay. So we know it's going to be the type of problem that we've been doing because it says is proportional, right? So what are they looking for? What's the question say?
It's asking for the initial.
And is that different from the other ones that we've done before?
Yeah.
We've never had to solve for the initial, right? That's where it's a little different. It's the same thing, but we're not having to, but they're not giving us the initial, right? So we're going to kind of start backwards. We're going to do every step, but we're going to start a little backwards. So what is the independent variable going to be here? Time, hours, right? And then bacteria, however they measure bacteria, we'll just put a capital B for bacteria. So I know it's 0, but I don't know how much bacteria is there. That's the problem. I don't know how much bacteria is there. That's what they want me to know. They said it triples every 4 hours, right? But I don't know how much that is. Right? But I do know that after 12 hours, there's 10 million. I'm not going to put 10 million, 0, 0, 0, just put 10. It'll be millions, bacteria millions. Okay. Okay. So let's set up what we need to set up. So we know it's dB over dt equals K times B, right? Let's skip all that other stuff. What is it going to end up being? What is it going to end up being when we're down, when we're down here? It's going to be the natural log of B, right? It's going to be, yeah, it's just going to be the natural log of B equals KT plus C, right? Yeah, let's try to skip those steps because it's just repeating itself, just different letters. And then it's going to be B equals E to the KT plus C, right? And then B equals E to the C times E to the KT, right? That guy represents our initial, right? Problem is we don't know that. We don't know what that number is. If we knew that, we'd be done. Okay? So what I'm going to do is I'm going to put a little placeholder there. I'm going to put a little placeholder there. Okay? I'm going to call it, since we don't know it, I'm going to call it C. Capital C. Okay? So I got B equals capital C times E to the KT. Okay. Now we got to solve for K, right? We got to solve for K. So how did we solve for K?
Divide by C.
Say it again.
Divide by C.
Not divide. Yeah, we would do that, right? We would solve. We would divide by C and everything, but the problem is I don't know what C is, right? So if I plugged in 12 and 10 million, if I plugged in 12 for T and 10 for B, I would still have two variables. I'd have capital C and K, right? So I can't solve for one unless I know what it is. So this is what I'm going to do. I'm going to go back to where it says, I know how fast it's growing, right? How fast is the bacteria growing? Every 4 hours, it's triples, right? So every 4 hours, how much is going to be there? 3C. That's the point I'm going to plug in. And I'll show you what happens. That's the point I'm going to plug in right now. So B is 3C. T is 4, right? So in other words, 3 capital C equals capital C times e to the 4K. Now when I divide by C, what happens? The C's cancel out, right? If I change it to a log, or sorry, yeah, change it to a log to get K down. It would be the natural log of 3 equals 4K, right? Divide by 4. So I get K equals 1/4 times the natural log of 3. And let me bring this guy down. So I got B equals capital C times e to the 1/4 times natural log of 3 times t, right? What do I do next? I know time and B, right? 12 is time. B is 10. Are there any variables left? Like, so if I do this, right? Now I can solve for C. Now I can solve for C, right? Now I can solve for C. So what you're going to do is you're going to divide by everything you don't want. Well, I don't want C to the 1/4 times the natural log of 3 times 12. E to the 1/4 times the natural log of 3 times 12. You'll get C. Okay, so we go 10 divided by, let's see, 10 divided by e to the 1/4. 4 times the natural log of 3 times 12. And I get a decimal. 0.370. 0.370. 0.370. Okay, so let me go put that back over here. Does that number make sense? It does, right? It does. So what does that mean? Does that mean 370,000, right? 370,000. So this guy represents bacteria started with 370,000. And then it tripled, it tripled, it tripled, it tripled. Every 4 hours it tripled, right? Until it got to 12 equals 10. Okay. So that was a little different because you had to solve for the initial. Okay, let's see if I can get this. Make this bigger. There we go. Okay.